These are notes on significant figures and scientific notation. So we're going to start with significant figures, and that's section 3.1 in your book. And significant figures deal with which numbers you count as significant, especially for things like rounding. So, back in 8th and 9th grade, maybe your teacher would say round to this many decimal places or something like that. So significant figures are actually rules so that you can calculate how many figures you should round to when you're adding, subtracting, multiplying, and dividing. The first thing we need to determine is what numbers are considered significant as far as numbers that you would need to take into account when you're doing operations. So here are some rules. I'm going to give you the actual rules first, and then I'm going to give you a pictorial device to help you remember the rules. So first of all non-zero numbers are significant. So any number that is not a zero is significant. So for example, if you have the number 232, that has 3 significant figures. If you have the number 12.61, that has 4 significant figures. The next rule is any zeros that are between non-zero numbers are significant. So in the number 607, there are 3 significant figures, the 6, the 0, and the 7. The 0 is significant because it's between a 6 and a 7. In the number 12.01, there are 4 significant figures because the 0 is between the 2 and the 1. And you're going to find when we talk about what numbers are not significant, it always has to do with zeros, because our first rule is all non-zero numbers are significant. So what numbers are not significant, it's got to have something to do with zeros. And finally, zeros to the right of a decimal place after a non-zero number are significant. So for example, in the number 4.00, the zeros come to the right of the decimal after a non-zero number, and so that has 3 significant figures. In 12.10, there are 4 significant figures. So this brings us to what numbers are not significant. Zeros to the left of the first non-zero number are not significant. So in the number 0.012, that only has 2 significant figures because both zeros come to the left of the 1, and that's the first non-zero number. In the number 0.102, there are 3 significant figures because the first 0 is to the left, so it's not significant. The second 0, however, comes between 2 non-zero numbers, and so it is significant. So the 1, the 0, and the 2 are all significant. Zeros at the end of a number without a decimal place are not significant. So for example, in the number 100, there's no decimal point, and so the zeros are not significant, so there's only 1 significant figure. In the number 10,200, 10200, there are 3 significant figures. The first 0 between the 1 and the 2 is significant. It's between 2 non-zero numbers. But the 2 zeros at the end are not significant. One of the things to note is this specifically says without a decimal place. Meaning if I were to say 100 and then put a decimal point at the end, that would actually be 3 significant figures because there is a decimal place. And I'm going to, again, kind of show you a little device to help you remember that. Then some numbers have unlimited numbers of significant figures. And that gets a little tricky. What we're going to say is when we're adding and subtracting and multiplying and dividing, we're not going to worry about these numbers, how many they have, because it's considered unlimited. So there are 2 examples of that. One is counting numbers. If you count a number of things, say you count 4 apples, the 4 is actually considered unlimited significant figures because you've counted something. The other one is exactly defined quantities have unlimited significant figures. So for example, 1,000 millimeters equals 1 meter. The 1,000 and the 1 both are considered unlimited significant figures because they are exactly defined quantities, as opposed to if you rounded, say something like 2.54 centimeters is 1 inch. The 2.54 is rounded, and so those numbers would be significant. You would say that there are 3 significant figures in that. That I know that last part is a little confusing, but what I want you to take away from that is when we are mathematically using these numbers, don't worry about how many significant figures counting numbers or exactly defined quantities have. So now, as I promised, I want to give you a little picture to help you remember. That's 6 different rules, but here's kind of how you can think about it. If you have a map of the United States, on this side you have the Pacific Ocean. On this side you have the Atlantic Ocean. And think about Pacific as standing for point present, point being the decimal point. And the A in Atlantic Ocean is going to stand for point absent, the A being for Atlantic being the absent. So the way this works is on your number, if you have a decimal point present, then you're facing this way or to the right going across the United States. And so all numbers to the right of the leftmost non-zero number are significant. So in this case, there's a point present in 301.0. 3 is our leftmost non-zero number. We're going to go all the way, think Pacific, it's all the way on the left. And so any numbers to the right of that 3 are significant. So this would have 4 significant figures. Whoops. 4 significant figures. On the other hand, let's get rid of those. If the point is absent, meaning there is no decimal point, such as in the number 1400, then we're starting in the Atlantic Ocean, and to get to the United States, we're going to have to go left. So in this case, all numbers to the left of the rightmost non-zero number are significant. So our rightmost non-zero number in this case is the 4. So all numbers to the left of that are significant. So in 1400, this would have 2 significant figures. I don't know why this is having such issues here. 2 significant figures. So that's sort of a little device to help you remember which numbers are significant and which numbers are not significant. So let's try some examples. So here are 4 examples. Go ahead and pause the video, write them down, and see if you can determine how many significant figures each one should have. So hopefully you got these answers. The first one, 0.2010, has 4 significant figures. If you go back up to the map, we have the point is present, so it's all numbers to the right. We're going to go to the right across the United States this way, so all numbers to the right of the first non-zero number are significant. In 3.00, we have 3 significant figures. Again, the point is present, so all numbers to the right of the leftmost non-zero number are significant. In 300, the point is absent, so we're going to go to the right, to the left across the United States. And so we're going to go to the left, all numbers to the left of the first non-zero number, and that's 3, are going to be significant. So that's 1 significant figure. Notice though, I added on, if you have 300 and you slap a decimal point in there, then you have 3 significant figures, because now your point is present, you're going in this direction. And then 0.005670, you have 4 significant figures, your point is present, and so everything to the right of the first non-zero number is significant. Hopefully that makes sense. Make sure you review this in your book, and let's move on. So I wanted, before we start to work with numbers, I wanted to quickly review scientific notation. Hopefully this is not new to any of you, but we use it a lot in chemistry because we work with really, really small numbers or really, really big numbers. And so scientific notation helps. I'm also going to show you how you can use scientific notation to your advantage when calculating significant figures. So, for example, 1.23 times 10 to the second. 10 to the second is 100. 10 times 10, 10 squared is 100. So that's essentially 1.23 times 100, or 123, which has 3 significant figures. Another way you can, a sort of trick I would say, is if you take the 2 from the squared and you simply move the decimal point over 1, 2, you get your 123. If we have a smaller number, 1.23 times 10 to the minus 2, 10 to the minus 2 is 0.01, and so we're moving the decimal point over, or if you were actually to multiply that on a calculator, and go ahead and do that to make sure you know what's going on. But the trick here is we're going to move the decimal point over 2 spaces to get us 0.0123, which also has 2 significant figures. And you'll notice if you go back to the original scientific notation, both of these clearly have 3 significant figures because they're all non-zero numbers. So if you have these examples, 24.2 times 10 to the third, that would be 24,200, 3 significant figures. If you have 61 times 10 to the negative 7, you would move the decimal point over 7. So we go 1, 2, 3, 4, 5, 6, 7, and you have this very small number. So now let's look at how we work with these numbers when we're manipulating them, adding, subtracting, multiplying, dividing. When you're adding and subtracting with significant figures, the rule is you're going to round to the least number of decimal places. One of the things I will say is if you're doing several things, if say you're taking an average, so you're going to add and then you're going to divide, you're not ever going to round until you're completely done with all your addition and subtraction and multiplication and division. So in order to get the right number of decimal places, you're going to round to the least number of decimal places, not significant figures, decimal places, when you're adding and subtracting. So go ahead and complete this problem here. And you can do it on a calculator. You don't have to do it in your head. And then see if you can figure out what you would round to. What would the number actually be if you are obeying the laws of significant figures? So if you add this up, you should get 37.699. But the rule says we're going to round to the least number of decimal places, which is this number here. 2.14 has 2 decimal places. So we're going to need to round that. Looking at 37.699, if I'm going to round that, I'm going to end up with 37.7. However, 37.7 doesn't have the right number of significant figures. So we need 2 decimal points. In order to get that second decimal point, what we need to do is go ahead and add in a 0 here, so that our answer is 37.70. And that would be the correct answer accounting for significant figures, which you will do in all of your calculations this year. So go ahead and pause the program and figure out what the correct answer for this one should be. So you should have gotten 31.84 for your actual difference, but then again we have to take significant figures into account. This number here has the least number of decimal places. It has 1 decimal place, and so we're going to round to 1 decimal place. There are more problems like this in your book if you want more practice with it. So now we're going to look at multiplication and division with significant figures. Slightly different rule here. Here we're going to round to the least number of significant figures. So let's take an example. Let's take 4.43 times 3.0. Go ahead and figure this out and then see if you can figure out how many significant figures you should round to. In this case, when you use your calculator, you should have gotten 13.29 as your product of 4.43 and 3.0. 3.0, if you go back to our rule, we're rounding to the least number of significant figures, not decimal points in this case. So the least number of significant figures is the 3.0. That has two significant figures. There's a decimal point present. Therefore, the 0 is significant. And so we're going to round 13.29 just to 13, and that would be your answer. Now, on your work, you don't have to write the whole product out and then round it if you don't want to. On a lab, usually we would see that. But if you're doing just problems and you in your head say, okay, 3.0, that's got two significant figures. I'm looking at my calculator and I'm seeing 13.29. I know I'm going to have to round. If you were to just write the 13, that's fine. That's absolutely acceptable. You don't have to make this a two-step process. So go ahead and calculate this division problem and then round to the correct number of significant figures. So in this case, looking at the calculator, you've got some really long, unwieldy decimal point here. And this is exactly why we use significant figures, so that everybody's rounding to the exact same decimal place. And so you've got this 0.537748 on and on and on and on, probably more than that. But the 30.2, that's three significant figures. And so we're going to round our answer to three significant figures. So it's 0.538. Again, there's more of these in your book, and we'll do some more in class. So make sure you're familiar with this. So now I want to do a couple of problems using significant figures and scientific notation. You're going to be using a lot of scientific notation this year, and so it's really important that you're comfortable with your calculator and that you know about what the answer is going to be, so you can tell if your calculator is wrong or right, in a sense. So let's do a couple of problems. Before we do that, let's just talk. So 3,000 would have one significant figure. Let's say, though, you have an answer that you need to have four significant figures for. Whatever you've done, you're supposed to end up with four significant figures. So you can change that to 3.000 times 10 to the third. That's still 3,000. But now you have four significant figures. So keep that in mind, that you can use scientific notation to kind of manipulate how many significant figures you have. All right, so what I want you to do on your calculator is these three problems. They're all multiplication. You're welcome to throw in some division if you like. I believe there's some in your book. But use your calculator, figure out the products, write the answers with the correct number of significant figures. Pause the video so that you can actually work through this and then check your answers. These should have been your answers. 1.4 times 10 to the 22nd, 2.4 times 10 to the 5th, 3.87 times 10 to the 25th. One thing I would say is make sure you know how to use your calculator. I at least find that calculators can vary a little, and the buttons can be in different places. And so, for example, on a test, I always want to be using my calculator that I've used. I don't always trust that I'm even going to press the right buttons to get the right exponents to give me the right answer if I'm using somebody else's calculator. And I end up taking a lot more time trying things in different ways, trying to expand numbers and put in all the zeros. And it's really important that you are comfortable using your calculator and that you know how to use it. If you don't know how to use it, please make sure you come and ask me about it so I can help you with this, because as I said, in chemistry, we use scientific notation a lot. This number down here, 6.02 times 10 to the 23rd, right there, you're going to find we use all over the place this year. That's a very important number. And so understanding how to use your calculator is really, really important. Please make sure you put any questions on the YouTube comments. And of course, in class tomorrow, we'll also talk about this. Have a good night.